Hi, this is Mrs. Wiest, and I'm here today to explain how to do a percent error calculation. Percent error is a way to measure experimental accuracy. The mathematical formula for percent error is the theoretical value minus the experimental value divided by the theoretical value times 100. In other words, we take the absolute value of what the answer was supposed to be, subtract what we got, divide by what it was supposed to be, and then multiply by 100 to make it a percentage. This formula is in your lab manual. Let's try an example now. The density of lead is 13.6 grams per cubic centimeter, but the measured and calculated value in lab was 12.9 grams per cubic centimeter. What was the percent error? You should be doing this problem along with me in your notes. So let's give this a try. Let me get my pen color going here. I think black's good today. Alright, so here we go. We're going to take the absolute value, 13.6, because that's what the answer was supposed to be. Whoops. And then we're going to subtract what we really got back in the lab, which was 12.9. And remember, that's an absolute value, times 100. Because we want our answer to be a percentage. And then that is all divided by what the answer was supposed to be, which is 13.6. Alright. So we take 13.6 minus 12.9 and we get 0.7. And don't forget times 100 there. And then we divide that by 13.6. So when I put all of that in my calculator, and round that off a little bit, I get 5.15%. Now most students ask me, well, is that accurate? Is 5.15% a pretty good percent error? And that's a hard question to answer because it really depends on what kind of measuring instruments you're using back in the lab. I would say for using our graduated cylinders and our balances that we have in our classroom, anything less than 10% is pretty good. So if you're wondering whether or not your percent error reflects accuracy, general guideline that we're going to use is less than 10%. Now on occasion we may do some labs where we want even lower percent error than that, maybe only 2 or 3%, but usually anything less than 10% is pretty good. Okay, let's go on to the next example here. And we have a student who measured the volume of water in a beaker, and they got the volume to be 125 milliliters, but the correct volume was actually 122 milliliters. What was the percent error? Okay, so let's set this up. We're going to have the absolute value. Oops, that looks more like an exclamation mark, doesn't it? Alright, absolute value 125 milliliters. And then we're going to subtract 122 milliliters. And it doesn't really matter what direction or what order we put this in, because remember, it's an absolute value. So if we take 125 minus 122, we're going to get 3. But if we take 122 minus 125, we're going to get negative 3. But since it's an absolute value, it's going to be 3 either way. So oftentimes students ask me, well, which one do I put first? And the answer is it doesn't really matter, because you just want to know the difference between the two. You're not worried about it being negative or positive. Alright, so we got times 100, and we want to divide by what it was supposed to be, which is 122. Okay, here we go. So I take 125 minus 122, that's 3, divide by 122, and then multiply by 100. Sorry about my messy handwriting here. Alright, and we're going to round that off to 3 digits because that's how many digits are in our measurements. So that would come out to 2.46%. Okay, that's pretty accurate, 2.46%. Now you should be able to answer these two questions. What is the formula for calculating percent error? And what does percent error actually measure? Keep practicing and we'll see you later.